Hello, everybody. Uh, Welcome to my session. My name is Dr. T. Rakesh, Associate Professor, Department of Electrical and Electronics Engineering from St. Martin's Engineering College. Today, I am giving a lecture about electrical and hybrid vehicles. So, I am start with the term hybrid. Generally, the term hybrid means it is a combination of two forms. So, here the automobile engineering, the term hybrid means it is a combination of two power sources. That means we are combining the IC engines with the electric motors, or IC engine with the gasoline engines, or IC engines with the flywheels, batteries with the flywheels, and charging capacitors also. This is the basic definition of a hybrid vehicles. So now I have start with the history of the vehicles. The first in the history, 1769 is a remarkable year for the automobile industry because Nicholas Joseph, he is the first inventor of the steam turbine. And then 1807 is the first inventor of the IC engine. And then 1830 is the Albert Robertson is the first inventor of the electrical vehicles. After that, 1860 year is the officially electrical cabs are come onto the roads. After that, the years 1890 to the 1924 is the golden era for the electrical vehicles. So this is the historical development of the electrical vehicles. So the next, I have to come with the how the electrical vehicles are evaluated from the IC engines. So in the year after 1924 to 1960 year is the golden era for the automobile industry because the IC engines are dominated the entire automobile industry because the electrical vehicles are a little bit having some disadvantages. So the IC engines are superior the electrical vehicles because in that years the natural resources of like oils are discovered and very cheaper, and the transportation necessities also increases. This all not meted by the electrical cars. That's why the IC engines will be dominated the automobile industry. And not only that, the marriage of the two yields of the hybrid automobiles for that to save the money, to reduce the negative impacts on the environment, and to reduce the negative impacts on the environment. After that, the engineers are recognized that the good features of the gasoline engines could be combined those of the electrical motor to produce a superior car. After that, 1997, the RD produces the first Duo, the first European hybrid car into the mass production. In 2000 year, Toyota Prius and Honda Insight, the first mainstream hybrid electrical vehicles are produced. These are the main components in the electrical vehicles. The first component is a motor. Here the different types of motors are used, the DC motors, AC motors, permanent magnet motors, and then the battery. Battery is the heart of the electrical vehicle, and then the transmission. The transmission will be provided the propulsion to move the vehicle, and then the motor controls and vehicle controls. These motor controls are the power converter, communication resistances, cooling systems, wireless communication modules, and sensors, actuators, and memories. And then the electrical and the vehicle controllers are these are electronic vehicle controllers to control the AC controllers, DC controllers, and hybrid controllers and inverters. And the next one is the how the IC engines are evaluated in converted into the green vehicle technologies from 1905 to the present year. From 1902 to 2000, the first model of engines are spark ignition engines, compression engines, and the electrical cars are the combination of batteries and fuel cells. From the year 2021 to 2030, the HCC engines and RCC engines. The HCC means homogeneous charge compression ignitions and reactive controlled compression ignitions, and the electrical vehicles are the combination of fuel cells and solar energy. After that, after 2030 to the next year, hybrid electrical vehicles are electric motors and HC engines. The electrical vehicles are dominated by the solar energy. And the next, the social and environmental impact of the hybrid vehicles are growing presence of the global warming and irreversible climate changes draws increased amounts of the concern from the world's population. The cars and trucks are responsible for the 25% of the CO2 emission need of high efficiency, clean and safety transportation. The electrical and hybrid vehicles and fuel vehicles has been typically proposed to replace the conventional vehicles in the near future. The air pollution emission causes the global warming, and petroleum resources depletion due to the use of the convention engines gave birth to develop the electrical vehicles. The next one is the advantage of the electrical vehicles. The electrical motors is far efficient when compared to the IC engines. The efficiency of the electrical motors is 75 to 85%, and the torque will be produced is also compared to the IC engines is very high. And EVs can use the regenerative braking during the during the running positions. The EVs can generate their own power and transmit to the battery, and batteries will be recharged. And hybrid electrical vehicles are more environmental friendly, and reduction in engine and vehicle weight, fuel efficiency is also increased, emissions also decreased. They cut the emissions, the global warming pollutants by 1/3 to 1/12. So reduce the dependence of the fossil fuels, 2 times more efficient than the conventional engines. The next one is the impact of the modern drivetrains. The modern drivetrain means it is a group of components that deliver power to the wheels, driving wheels. Drivetrain is a series of parts that works together to transform the rotational power, produce the engine to the wheels so car can move. The couple of the engine that produces the power, the driving wheels that can use the mechanical power to rotate the axle. So the operating speed of an engine and wheels are also different and must be matched by the correct gear ratio. As the vehicle speed changes, the ideal engine speed must remain approximately constant for the efficient operation, and this gearbox ratio must also be changed either manually or automatically by an automatical continuous variation. So there are four different types of drivetrains we can use in vehicles. The first one is the rear wheel drive and front wheel drive and all wheel drives. The first we have to go for the rear wheel drives. The power is transferred from the rear wheels to move the car. This arrangement have many benefits compared to the front wheel drives. The distribution of weight more equally to each tire, which in turn provides a better streaming and handling, offers superior braking compared to the front wheel drive wheels. A rear wheel drive train splits the job on steering and driving the vehicles, lead to better handling. So handling acceleration, back wheels only have to move the car in front wheels. The example for the back wheels rear wheel drive is Lexus IS series and BWM 3 series. The next one, the main parts in the rear wheel drive are the first one is the first one is the transmission, and the second one is the drive shaft, and the third one. The transmission is responsible for providing the propulsion to move the vehicle in a forward direction. In the drive shaft, this will be converted the kinetic energy into rotational energy. And then with the differential, the term differential means it is a melanized seized part, sits between the two rear wheels in the last stop of them to spin, which in turn move the car. So these are the basic parts of the universal giant U and the differential parts, and this is the diagram of the rear wheel drive. Next, we have to move to the front wheel drive. So the front wheel drive, all the components of drive same similar to the rear wheel drive. It having transmission, drive shaft, and the differential. So here the drive shaft is reduced to transaxle and half shaft. Though the transaxle combines the transmission different into a single shaft, and the half shaft, the front wheel don't need the long drive, transfer the torque to the wheels instead of the half shaft connections from the transaxle to the vehicle assembly. This is the block diagram of the front wheel drive. And next one is the all wheel drive. All wheel drive means the entire torque will be transferred to the four wheels of the vehicle, and it is mostly used in slippery and wet roads. The next one is a four wheel drive. The four wheel drive is similar to the all wheel drive. Here we are having the parts of the all wheel drive. The first one is the internal combustion engine and the clutch and gearbox, and the rear differential, rear propeller, and the transfer case, front propeller and front differential, and the couple of devices. And next, the impact of the modern drives on energy supplies. Nowadays, we are using the electrical vehicle charging station that will create a lot of disturbances to the present existing grids. In that, first one is the voltage instability, because EVs are charged in various periods of time. The power grid will be disturbed due to the charging station, because the charging is having a electronic devices that will create the harmonics, and that will be disturb the voltage stability. So these are the basic causes, non-linear characteristics of load damping oscillation due to the charging and discharging of the batteries. So for these possible solutions are wide area monitoring methods we are using presently. We have to improvise more number of models to improve the voltage stability. And the next one is the harmonics. The major causes for the harmonics are in electrical vehicles we are using the motor controls and vehicle controls. These are all built up with the electronic devices. These all electronic devices will create some noises and harmonics injected into the AC system. So these are the total harmonic distortion formula. And the possible solutions is we have to use the different load patterns, different EV charges produce the different phase angles and magnitudes, eliminate the pulse rate modulation, and EV charges THD can also be avoided by the using active and passive filtering elements. The next one is the power loss. The power loss is the main causes for the power loss is uncoordinated charging stations of power loss stream, power transmission at higher distance. So for these possible solutions are coordinating the charging stations. Techniques can be used in low peak hours, and the power generated is nearby the vicinity will also help in the reduce the such power losses. And next one is the overloading of the transmission transformers. Extra heating is generated by EV charges, increase the rate of aging of the transformers. Colder region negligible study said 10% of EV penetration will not affect the light of the transformer. So the possible solutions is using charging below the penetration percentages. The next one is the power quality degradation. Major EV penetrations to grid will increase the harmonics and voltage imbalances and increase the amount of harmonics. For this possible solution, we have to maintain the level of penetration. So the next one is dynamics of the electrical and hybrid vehicles. So first one, we have to learn, we have to design an electrical vehicle. First we have to how the IC engine will be works, how the propulsion torque will be produces, how the movement will be happen, what are the factors affecting the movement will be, we have to learn in this section. The first one is motion and dynamic equation of a vehicle. This includes a simple normal physics. That means the IC engine works on the principle of Newton's second law. The Newton's second law states that the acceleration of any object is directly proportional to the force exerted on it. So this is the Newton's second law. Based on the Newton's second law, the motion of the vehicle will be happen. So here the force on the propulsion unit helps to vehicle to overcome the resistant forces due to gravity, air, and the tire resistance. The acceleration of the vehicle depends mainly on the four terms. The first one is the power delivered by the propulsion unit and the tire resistance and the road conditions and aerodynamics of the vehicle and the composite mass of the vehicle. So here I have to give the general description of the vehicle movement. So previously we learned from the movement of the vehicle is depends upon the Newton's second law. So here we can simplify that Newton's second law into simplified equations. The first one is the vehicle motion can be completely determined and analyzing the force acting on the direction of the motion. The force acting on the moving up upgrade, it can be here. Okay, here I'm considering a vehicle. It will goes in upward direction. The force acting on the forward direction is the forward force. Here, the resistive forces are defined as the rolling resistance, aerodynamic drag, and uphill resisting. Using the Newton's second law, I have derived the equation dV by dt is equal to sigma ft minus sigma f resistance into delta m, where v is the vehicle speed, acceleration of the speed, and where ft is the total propulsion force produced by the engine, and where f resistance is the resistive forces oppose the motion of the vehicle, and m is the total mass of the vehicle, and delta is the mass factor conversed by the rotation. Here I am considering, first of all, I have to find out the resistive forces to opposes the motion of the vehicle. So the first one is the rolling resistance. The rolling resistance on a tire or a hot surface is due to the hysteresis in the material. In this figure, I have to show that a tire is standstill shown on this tire of a force P acting horizontally. The pressure in the contact area between the tire and the ground is distributed symmetrically to the center line, and the resulting force PA is aligned along with P. When the tire rolls, the leading rolls contact area loading and trailing off is the unloading. Thus, the pressure on the leading half is greater than the pressure on the trailing half. It can be showed in a figure 4a. In that, this phenomena results the ground reaction for shifting forward direction, and the shifting of the ground reaction force creates a moment that opposes the rolling of the wheels. On soft surfaces, the rolling resistance mainly caused by the deformation of the ground surface. It can be showed in this figure. In this case, the ground reaction force almost completely shift to the leading half of the tire. So here we can simplify all the equation. The rolling resistance of equation can be expressed as a PA is equal to MA, where TR is the rolling resistance in Newton, expressed in a Newton meter, where P is the normal loading acting on the center of the rolling wheel. So M is equal to mass of the vehicle. It can be expressed in a kg, and G is the acceleration, and A is the deformation of the tire. To keep the wheels rolling, a force F are acting on the center of the wheel. It requires balance this rolling resistance moment. This force is expressed in Fr is equal to TR by R divided that PA by V. This can be simplified into rolling force is equal to rolling resistance force is equal to PFR, where P is the normal loading acting on the center of the rolling wheel, and Fr is the rolling resistance coefficient. Now, when the vehicle moving up in a gradient, the normal force P in equation 4 replaced by the component that is perpendicular to the road surface. Hence, the equation can be rewritten as Fr is equal to Pfr into cos alpha, where F is the constant can be replaced as mgfr cos alpha, where P is the normal loading acting at the center of the rolling wheel, and it can be expressed in a Newton meter. We can name it as the fifth equation, and then where Fr is the rolling resistance coefficient and alpha is the road angle. Now we have to move to the rolling resistance coefficient. Fr is the basic function of the tire material, tire structure, and the tire temperature, tire inflammation pressure, tread geometry, and the road roughness, road material presence and absence of the liquids on the road. The next one is the next factor affecting the movement of the vehicle is the aerodynamic drag. A vehicle traveling in a particular speed, the air encounters a force acting on the vehicle. It results its motion. This force is known as the aerodynamic drag. The main causes of the aerodynamic drag is, the first one is the shape drag, and next one is the skin effect. The shape drag is due to the shape of the vehicle. In a forward motion, the vehicle pushes the air in front of it. However, the air cannot distribute instantly move out of the way. So it will take time and it will create a pressure, thus increase it. This pressure results in high air pressure in front of the vehicle. In the similar manner, in the backwards, the air behind the vehicle cannot instantaneously fill the space left by the forward motion of the vehicle. This will create a zone of low pressure. These two pressures will affect the motion of the vehicle. This can be explained with a simplified diagram. Here the vehicle moves in a forward direction. The air will be affect the forward motion of the vehicle. Here it creates a high pressure area, here the low pressure area. This can be explained with a simple equation. The aerodynamic drag resistance is Fw is equal to half rho AF CD V square. Here rho is the density of the air, AF is the vehicle front area, and V is the vehicle speed, and CD is the drag coefficient. These are the different coefficients. Aerodynamic drag coefficient will affect the vehicle design. And the next one is the skin effect. The air closest to the skin of the vehicle, the almost speed of the vehicle, while the air away from the vehicle remains still between these two. The molecules move a wide range of speeds. So the difference in speed between air molecules produce the friction. This friction results the second component of aerodynamic drag. This will affect the moment of the vehicle. So here we can express the various aerodynamic coefficient for the different types of vehicle. Here motorcycle with a ride of it having a coefficient of 0.5 to 0.7, and it's a vehicle front wave is a 0.7 to 0.9. In the same way, we have different vehicles, we have expressed the value of aerodynamic drag coefficients. And the next one is the grading resistance. The grading resistance is also one of the component which will affect the movement and motion of the vehicle. So when a vehicle goes up or down a slope, its weight produces a component force that is always directed downwards. It can be expressed in this figure. This is our vehicle weight will be always applied the downwards of the earth. So this force component opposes the forward motion of the vehicle and the grade is climbing. When the vehicle goes downward grading, this force component aids the vehicle motion. The grading resistance can be expressed as Fg is equal to mg sine alpha. Here m is the mass of the vehicle and g is the acceleration constant and alpha is the road angle. So finally we can conclude the all resistive forces joined together. So here the grading resistance F is equal to Fg plus Fr mg Fr cos alpha plus. So next we have to move on to the acceleration resistance. In addition to the road resistance, tire resistance and aerodynamic drag and gradient resistance, another resistance will opposes the motion of the vehicle. That one is the acceleration resistance. In addition to the driving resistance occur in the steady state motion, inertial forces also occur during the acceleration and braking. The total mass of the vehicle and internal mass of those ratings parts of the drive, accelerated or brake are the factors influencing the resistance acceleration. This can be expressed Fa is equal to m plus sigma j ROT by the R square dy by dm. So here this can be simplified into acceleration resistance Fa is equal to delta m dv by dt, where delta is the rotational inertia constant and m is the. So finally we can conclude the total resistive forces combined together. We can write an equation F resistance is equal to Fr plus Fw plus Fg. This is the resistive forces. Now we can substitute this equation in our acceleration equation. This is the dynamic equation of the vehicle. Here the dynamic equation, for the longitude direction, the major external forces acting on the two axial wheels that can be expressed in the figure. The rolling resistance in front of the rear is Frf and rear wheel is Frr, which are represented by the rolling moment Trf and Trr. The aerodynamic drag Fw and the grade climbing resistance is Fg and acceleration resistance is the Fa. So the dynamic equation of vehicle motion along with the longitude direction can be expressed as m dv by dt is equal to F df plus ftr, propulsion produced by the front wheel, propulsion produced by the rear wheel, minus the resistive forces offered by the front wheels and the rear wheels. This can be expressed in equation 16. The first term on the right side the total tractive effort and the second term is the total tractive resistance. To determine the maximum tractive effort that the tire ground cannot support the normal loads on the front and rail axles have to determine by summing the moments all the forces about the point R, the center of the tire ground area. The normal load on the front axle Wf can be determined by we can substitute that equation in this. Wf is equal to mjlg cos alpha minus the tractive forces Trf, propulsion forces because of the front wheel and rear wheel, and F HWs and mg hg sin alpha and mg. So the next, similarly, the load applied on the rear wheel we can express it in this equation mg La cos alpha minus propulsion tractive effort produced by the rear wheel Trf plus Trr by the L. The next one we can simplify all the equation. We can write the final dynamic equation of a vehicle is equal to Wr is equal to Lal by the mg cos alpha minus hg by the Ft minus Fr1 minus R dy by gd. And next, because of the load applied to the rear wheel is equal to, this is the final equation, load applied to the rail wheel, and this is the final equation for the load applied distributed on the front wheel of the equation. So now the maximum tractive effort that the tire ground contact can support described by the product of the normal load and the coefficient of the road adhesion. It can be expressed in a table, third table. The road speed, if we were taking as the 50 kilometers, the coefficient of the road adhesion for dry roads is the 0.85 and the coefficient of the road for the water roads are the 0.65. For the similarly, for 90 km speed we have considered the coefficient of road adhesion is 0.8 and the coefficient of road adhesion for the water roads is 0.6. And for the we have to take in a speed more than 130 km per hour, the coefficient of road adhesion for the dry roads is 0.75, for the water roads is 0.55. So now we can conclude the maximum propulsion torque produced by the front and rear wheels can be expressed as Ft max is equal to mu mg cos alpha Lb plus Fr hg minus Rd by L 1 plus mu hg by L. In the similar manner for the rear wheel driven vehicle, Ft max is given by the mu mg cos alpha La F for hg or divided by L total divided by the 1 minus mu hg by L. In the vehicle operation, the maximum tractive effort can be driven wheels transferred from the power plant through the transmission should not exceed the maximum value that are limited by the tire ground cohesion. Otherwise, the driven wheels spin on the ground, leading to the vehicle instability. The next one is the adhesion and dynamic wheel radius and slip. So, when the tractive effort on the wheel exceeded the maximum tractive effort limit imposed by the adhesive capability between tire and the ground, the driven wheels will spin on the ground. So, the adhesive capacity between the tire and the ground, the main limitation of the vehicle performance, especially when the vehicle is driven on wet, icy, snow covered or soft soil roads. So, the maximum tractive effort on the driven wheels transferred from the power plant to the transmission should not exceed the maximum value given by the equations in the previous equations 24 and these two equations. The next one is the driven slip wheels is St is equal to omega r radian minus V by omega r dy n, where angular speed of the tire, the dynamic wheel radius is calculated from the distance traveled to the revolution of the wheels rolling without slip. The dynamic wheel radius is calculated from the distance traveled at 60 kilometers per hour. The increased tire slip and higher speeds roughly offset increases in R dy n. So, the value of R dy n for different tire series are given in this table. Now, I have to conclude the entire topic. Now, I have to explain in simplified electrical hybrid vehicle in a video. So, this can be the how hybrid vehicle will be operated. So, here the hybrid electrical vehicle, it is a combination of the IC engine, electric motor and the battery. So, IC engine is responsible for the production of the propulsion torque to move the rear wheels, and it is also generates the power to recharge the battery and to run the motor. So, here the IC engine will be provide the torque to move the vehicle in a forward direction. So, engine generates the electricity. This will charges the battery. How the engine will charges the battery here? This engine will be operated with the fuel on a surface of a smooth surface. This is the dynamic force engine, and then engine will generate the engine having a displacement of 1 to 2.5 liters, and it is having a low torque, and the power output is 60 to 150 bhp, and the torque output is 80 to 200. It is very, very less when compared to the electrical motor. The advantage of electrical motors are having higher outputs provided the increased torque, and that torque is used while in a low speed regions. Here the motor will be take the energy from the battery and produces the propulsion torque, and having high voltage, it provides the 200 to 400 volts, high power output, the high torque speed characteristics, and increases very instantaneously, and it will the battery pack having a series of batteries will be charged. It is generally the lithium ion batteries we have to take in. Here the all lithium ion batteries will be in a series. This can be charged by the generation produced by the torque engine. Here the series of lithium ion batteries, these are the pack of the batteries in a vehicle. The hybrid electrical vehicle will be operated in 3 modes of operation. The first one is the driving modes, the fully electric mode, and the hybrid mode and power generation mode. In the fully electric mode, here the IC engine does not operate it. The power splitter can be split the engine from that. Here the motor will be operated from the battery. It will charge, and then it will provide the propulsion torque to move the vehicle. So, this is the responsible, and then it is a silent operation and zero emission, and it produces very less noise, and the pollution is also very zero. This drive can be used in low speed drives. It is very useful and effective for the city transmission, and emission of fuel is also very, and it is also economic and reduces the air pollution. And for electric motors for the high instant torque, it can be used in very high density traffic areas. So, the next one is it is more efficient for the low mode of operations, and IC engine is well Next one is the hybrid mode. The combustion engine and electric motor both will be operated in the same period. IC engine, these is for the long drives, and during this period IC engine will uses the very less fuel and fuel efficiency is more, and electric motor is in this period of operation, electric motor will be very much, and it can be, this IC engine can generate the power and transmit it to the battery for the charging purpose, and the IC engine is also responsible for producing the torque to rotate. So here I have to concluded. Today I will give the entire introduction how the electrical hybrid will work, hybrid vehicles will be work. Thank you.